today, I am tasked to discuss the two of the four types of credit market instruments, which are the coupon bond and the discount bond. Coupon bond pays the owner of the bond a fixed interest payment or coupon payment every year until the maturity date, when a specified final amount, face or par value is repaid. The coupon bond payment is so named because the bond holder used to obtain payment by clipping a coupon off the bond and then sending it to the bond issuer, who then sent the payment to the holder. A coupon bond is identified by four pieces of information. First, the bond's face value. Second, the corporation or government agency that issues the bond. Third, the maturity date. And lastly, the bond's coupon rate. The present value of the bond is calculated as the sum of the present values of all the coupon payments plus the present value of the final payment of the face value of the bond, or simply by the formula P equals C over 1 plus I plus C over 1 plus I raised to the power of 2 and so on to C over 1 plus I raised to the power of n plus F over 1 plus I raised to the power of n, where P is for price of the coupon, C is yearly coupon payment, F is for the face value, N for years to maturity, and I for the yield to maturity. So an example problem: find the price of a 10% coupon bond with a face value of 1,000, 11% yields to maturity, and 3 years to maturity. For the solution, first you have to write down the formula and then do the substituting. So it would be now P is equal to 100, which is the coupon payment, over 1 plus 0.11, which is the yields to maturity, plus 100 over 1 plus 0.11 raised to the power of 2 plus 100 over 1 plus 0.11 raised to the power of 3, which is the years to maturity, plus 1,000, which is the face value of the bond, over 1 plus 0.11 raised to the power of 3. So you would have an estimated answer of 90.09 plus 81.16 plus 73.119 plus 731.191, or the total would be 975.56. That's your price of the coupon bond. So table 1 shows the yields to maturity calculated by several bond prices with a 10% coupon rate, a 10 years of maturity, and a face value of 1,000. So in this table, there are 3 interesting facts emerge. So these are the following. First, when the coupon bond is priced at its face value, we can see in the table that the yield to maturity equals the coupon rate given. Second, we can see in the table that the yield to maturity and the price of the bond are negatively related. That is, if the yield of the maturity increases, the price of the bond decreases. And if the yield to maturity decreases, the price of the bond increases. So therefore, we can see that both are inversely proportional to each other. Lastly, we can observe that the yield to maturity is greater than the coupon rate when the price of the bond is below its face value. So one case of coupon bond is worth discussing because its yield to maturity is particularly easy to calculate. This bond is called console or perpetuity bond. It is a perpetual bond with no maturity date and no repayment of the principal that makes fixed common payments of forever. Consoles were first sold to British Treasury during the Napoleonic Wars and still traded today, but they are quite rare. The formula for getting the price of the console is P is equal to C over I, where P is for the price of the console, C for the yearly payment, and I is for yield to maturity of the console. One nice feature of the perpetuities is that you can see immediately that as yield to maturity increases, the price of the bond falls. For example 1, if perpetuity pays for $100 per year and forever, and the interest rate is 10%, using the formula discussed earlier, and that would be 100 over 10%, your price of the console would be 1,000. And for example 2, the console payment, yearly payment is same, which is $100, but the interest rate or the yield to maturity is increased by 10%, which is now 20%. So using the formula, same formula, $100 divided by 20%, so that would be 500. The price of the console is $500. So now we can observe in the two examples that example number 1 having a 10% interest rate gives a higher price of the console, which is $1,000, than the example 2 having greater interest rate, which is 20%, and gives answer the price only for $500. So therefore we can conclude that the yield to maturity is inversely proportional to the price of the console. So what if the yield to maturity is not given? So this formula would help, which is I is equal to C over P, where I is for the yield to maturity and C is for the yearly payment of console, and P is for the price of the console. This formula is driven from the original formula in finding the price of the console, which is P is equal to C over I. For example problem, what is the yield to maturity on a bond that has a price of $2,000 and pays $100 of interest annually forever? So for the solution, let's just substitute the given by the formula discussed earlier, which is I equals C over P. So 100 over 2,000 is equal to 0.05 or 5%. So your yield to maturity is 5%. So next up is the discount bond. So it is also called a zero coupon bond that is brought a price below its face value, and its face value is to be repaid at the maturity date. Unlike a coupon bond, a discount bond does not make any interest payments, but it just pay off the face value. For example, a 1-year discount bond with a face value of 1,000 might be brought for $900, and in years time the owner would be repaid the face value of $1,000. The formula in getting the price of the discount bond is P is equal to F over 1 plus I, where P is equal to, of course, the price of the discount, and F is for the face value, and I is for the yield to maturity. Treasury bills, US saving bonds, and zero coupon bonds are some examples of discount bonds. The formula in getting the yield to maturity of a discount bond is I is equal to F minus P over P, where I is equal to the yield to maturity, P is for current price of the bond, and F is for the face value. This formula is driven from the original formula in getting the current price of the discount bond, which is P is equal to F over 1 plus I. So for an example problem, discount bond such as a 1-year US Treasury bill which pays a face value of 1,000 in 1 year's time, if a current purchase price bill is $900, so find the yield to maturity. So simply by following the formula in getting yield to maturity of a discount bond, which is I equals F minus P over P. So substituting the information given, so it would be now I equals 1000 minus 900 over 900. So the answer would be 0.1111 or 11.11%. So the yield to maturity in this problem is 11.11%. That's all for my report. Thank you and be safe always.